All right. So this is what we call integrals of composition or composite functions. Right? And what it is called is kind of like pattern recognition. So let's see. Let's get the derivative of this function. What would be my derivative here? Sine of 3x. What do we get? 3 cosine of 3x, right? So let's pretend that we had an integral problem. We don't have this here. We don't know that this was the derivative of this guy. But we have an integral problem that just shows 3 cosine of 3x. How am I supposed to know right away that the answer is going to end up being this guy? Just by integrating this function. That's what it should be. Plus c though. What kind of a pattern did it fit so that I would know that it would be that? What would the u be in this particular problem if we're just looking at 3x, right? And what would du be? It would be 3 dx, right? But do I have that 3 there? Or do I have that dx? So technically would those guys go away and would it be just like cosine of u?
Yeah.
The derivative of, the antiderivative of that would just be sine of u, right? Which in this case was 3x. So what is it that we're kind of looking for in order to be able to jump to that step without having to show all that? What has to be in the problem? What do you think? So that I don't have to go through all this and write it up. This was 3x. And its derivative was what? 3. So what has to be there? The derivative of whatever u was, right? So as long as you see that derivative being in there, a part of that problem, you can technically ignore all those parts and just integrate it as if that were just a u. To keep bringing that argument down. You understand? Clear? Look at the next one. What would be my derivative on this one? 5 over 5, right? Times x squared plus 1 to the 4th. Times what? 2x. Which is really just x squared plus 4. Plus 1, sorry. To the 4th times 2x. Yes? So let's pretend that they ask you to integrate that problem. X squared plus 1 to the 4th times 2x. How am I supposed to pick out that it follows one of those particular patterns? What would we put as u in this case? X squared plus 1, right? Then we would say the derivative of that. So do that in your head. What's the derivative of x squared plus 1? 2x. Is it there? 2x dx, right? So that means these two guys go away technically. This is u. U to the 4th. Can we integrate that quickly? Alright, so let's do it. What would be the antiderivative? X squared plus 1 to the 5th divided by 5, which is that 1/5. Let's see, did it bring us back to what the original function was over here? Which is what we know should happen when I have the integral of the derivative. What's kind of being the pattern that we're noticing? What has to be provided for us? The derivative of that inner function, right? That u. Cool? One more. What's f prime going to be here? 2/3 times 3 over 2, right? So those cancel out. X to the 3rd plus 1 to the what power? 1 over 2, because we're taking away 1. Times what? 3x. These guys go away. We're left with x to the 3rd plus 1 to the half times 3x. So if they were to ask me to integrate this without knowing anything, without knowing that that was the derivative of something, how could I get its derivative quite quickly? What do we notice? This would be my u, what would be my derivative? 3x squared dx. Boom, there's my derivative, right? Okay, that's what we're going to call the license to integrate. Okay? So you gotta have the license in order to integrate it, right? So this is my license to drive, okay, to keep moving forward. So that goes away, something to the half, add 1 and divide by the new power. Quick, what do we get? X to the third plus 1 to the 3 over 2, divided by 3 over 2, which is times 2 over 3, plus, is that the same answer as the first one? It should be. Easy? Starting to be able to recognize a particular pattern. If you were to be given any of these problems, you can quickly get through them by recognizing those patterns. Now, could you still use U substitution and go through the whole thing?
Yeah.
Yes, I'm just trying to show you a method to make your life a little bit easier. All right, the last one here. What is this the same thing as? X squared plus 3 to the half, okay. So what would its derivative be? 1/2 x squared plus 3 to the negative half times 2x. Now let's get the integral of that. 1/2 times x squared plus 3 to the negative half times 2x dx. What do we look for? So this is u. Do we have the license to drive, to integrate? What's the derivative of this? 2x. Is that somewhere in the problem? Yeah. Okay, except we still got this 1/2 here, right? That's not a problem, right? We can just pretend he was out there. Or we can continue bringing him down. So we got 1/2 parentheses x squared plus 3 to the what power now if we added 1 because we're integrating? To the 1/2 divided by half, which is really times 2 over 1. So does that cancel out? And are we left with the original problem? Plus c? Yes. Is that cool? So anti-differentiation by pattern recognition, okay? So we know that if I get the derivative of the composition of these functions, the derivative would be f prime times g of x, f prime of g of x times g prime of x. And then if I integrate that derivative, which is what they're doing down here, what should my answer be? F of g of x. Go back to the original function, plus c, right? So what's giving you that license to integrate is being able to recognize that you have the derivative of that inner function that we're technically calling or have been calling u. You understand? You want to check for that. There's going to be some problems where you don't have the license, right? There's people that drive without licenses. Okay? There's going to be some that have only a permit. Okay? So they have a permit, but they don't have the full license. They just have the permit. So they shouldn't be driving by themselves. They should be driving with someone else. Okay? There's going to be some that don't have the license at all. Oh no! Okay? So we need to fix that. We need to make a fake ID.
Like Uncle Wes.
Okay?
Like 2 blocks away.
Alright, so this guy right here is what we call the license to integrate.
It's okay what I do this.
It's your license to integrate what is left over as normal, okay? You could technically ignore all that and just integrate it, boom. It'd be good to go. Got it? What you're trying to look for is to see if that pattern exists. I got 6 examples, I don't know, 8 examples. That should go by quite quickly, because we're applying this particular little trick here. Let's give it a try. Look at that first one. Does this person have that license to integrate? Yes? What would be U? 3x, what's the derivative of that 3? 3. So does he have the license? Yes. Alright, so ignore this, get the integral of cosine. What's the integral of cosine? Sine, so my answer is just sine 3x plus c. Boom, quick. Look at the next one. Do you want to rewrite it before we jump into it? Some people have been getting this 3 as part of the cube root confused with the power of that x. Okay? So this is really 2x times x squared plus 5 to the 1/3 dx. So let's write it like that so we don't get confused. So what would be u here? Okay? Does he have the license? He gets pulled over. We ask him, do you have the license? What's his license? 2x, is it there?
Yeah.
Alright, so he's got it. So we're ready to go. Right? You can write a mistake in. So integrate it. X squared plus 5, if we add 1, we get how much? 4/3. Divided by 4/3, which is times 3/4 plus. Quick. Check the next one. Can I see your license and registration? Does he have it? Yes, alright. Okay, I'll give you a warning. Alright, so anyways, let's integrate this bad boy. So now we're just integrating sine. What's the integral of sine? Negative cosine of 2x plus 3 plus what? C. Good? Alright. On this one, we're going to change the problem because I thought it was going to work out nice and easy, but it doesn't. You need to know some information that I haven't taught you yet. So we're going to change it. We'll rewrite it, okay? And for this one, rewrite it as 4x to the 3rd times sine of x to the 4th dx. Let's work it out. We get pulled over. We ask for the license. Do we have it?
Yep.
Yes? What's the license? Right, 4x to the 3rd, which is the derivative of that guy. So we can integrate as normal, ignoring this, right? So what would that be? Negative cosine of plus c. Easy? Good? Try the next one. What's going to happen there? Woo! Let me see your license. What's his license? What should his license be? 3. Uh-oh. What happened?
Going to jail.
No license. So this guy got to pop out his little pocket printer and make a fake ID real quick, okay? Alright, so what should the license have been there? A 3, right? So is there a way that you can think of that we could rewrite this problem so that when I put a 3 here, mathematically it's the same as the one that I have there? If I put a 3 there, what would I have to put on the outside to cancel it out? So technically it's the same problem, it just looks different. A 1/3, so could I do that? So now is it technically the same problem? But now does he have a license that he made using his pocket printer? Yeah? Alright, cool. So now we can integrate this like normal, right? Because now we got the license and we're good to go. So what's the antiderivative of cosine? Sine, except now I have this 1/3 of that. Are we okay? All I did was add some makeup to that girl because less. But it's still the same girl, right? We just made sure she got a nice note. Okay? Actually, we could say she has no license, so we gave her a what? A permit. Okay. How about this one? Does this one have a license? No?
Not the right license.
Not the right license?
She has a permit, not the
She has a permit, not the license, right? Why does this one have the permit? Because this is 2x, right? And then they got a 3x there. Oh, man. So let's see, what could we do? This is like the integral of 3x times x squared plus 2, right? To the half dx. So this right here is what we would say it would be the what? A permit? Permit, but there's no adult in there. She has one of her little friends that doesn't have a license either, right? Missing a licensed driver.
How much they writing on that
It helps us learn.
It helps you learn, right?
Yeah.
Okay, so we're gonna take out that 3 and we want there to be a what there? A 2, right?
Yeah.
So what do I have to put on the outside to cancel that 2 out so that it doesn't affect my problem? A 1 over 2, right? Are we okay? We can do anything we want to a problem, right? I just did. Okay? This type of this makes it go away and it's the same as that one, right? Are we okay? I'm not making this stuff up.
Sure.
These are legal moves, okay? Trust me, you won't go to jail.
The way you said it.